This video is the first of 4 videos which will derive the kinematic equations. The kinematic equations are a set of 4 equations that are useful for solving problems of motion with constant acceleration. You must have constant acceleration to use these kinematic equations. If you don't have constant acceleration, sometimes you can find workarounds, or you actually need calculus to be able to solve the problems. There are new concepts in these equations. They just make solving many problems more convenient. We will begin by considering only problems in one dimension. Let's start with the equations we have learned so far, that the average velocity is displacement over time, and that the average acceleration is change in velocity over time. For ease, we will drop the vectors above vector quantities, but still use positive and negative signs to denote direction. We will also assume that time starts at t equals 0, and we'll place the origin at the initial position so that x naught equals 0, and we can just abbreviate delta x to x. With this, we have the following important variables. X equals our displacement, t equals the time elapsed, v naught equals initial velocity, v equals final velocity, and a equals acceleration. So let's begin with the first kinematic equation. Dr. Perry is initially jogging at 2 meters per second. He accelerates at a constant rate of plus 3 meters per second squared for 2 seconds. What is his final velocity? We first start out by writing down the given information and looking for what we're solving for. And then we can see that the equation that we have been using already for average acceleration, which if you have an average acceleration and constant acceleration, those two will be the same. We can use this equation and rearrange it to solve for the final velocity. And then if we plug in our information, we get 2 meters per second plus 3 meters per second squared times 2 seconds gives us 8 meters per second. Now let's stop for just a moment and recognize that we could have solved this problem without actually using the equation, but just an understanding of what acceleration is. So if we have an acceleration of 3 meters per second for 2 seconds, that's going to mean that we gain velocity at 3 meters per second every second that passes. So if we start out at 2 meters per second, after the first second we'll be going 5 meters per second, after the second we'll be going 8 meters per second. But this brings us to our first of the 4 kinematic equations, really just rewriting our initial equation that we've already been talking about, where average acceleration is now just the constant acceleration. So v equals v naught plus at.